Happy Monday, everyone. Again, I told you that there was a little stretch here where I'll be out several days, and this should be the last of it. This would be the last time I'm missing for golf, which is exciting for sure for me, and I hope for you. Maybe you don't really care that I'm gone. You might actually enjoy it. But anyways, let me just kind of give you a breakdown for the week real quickly. So today we're gonna do what we've been doing with very, 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 very slight modifications. In fact, there are ones that we've done already. But again, we moved on to solving polynomials by factoring. So now we factored polynomials. Now we're going to solve them. So you already kind of know the deal. That's today. Tomorrow, when we come in, I'll go over the questions that you're going to have for your assignment tonight. And then following that, you're going to be given, and I'll be here tomorrow, you'll be given a review. That's going to be your second test for this 9 weeks. So Tuesday you'll get it. Wednesday we'll go over it. So you'll have a good portion of the class tomorrow to work on it. If you have questions, you can come up and ask me. I can meander around the classroom, and then Wednesday I'll go over it, and then Thursday you'll take your test. So the reason I'm spending a little bit more time is because we've only had 2 tests. Again, I have those graded, just need to enter them. In fact, I hope to do that tomorrow while I'm out there. That's my goal. It might not happen, but I promise you this. It will be definitely posted before I come back to class on Tuesday. So I hoped to give you plenty of time to prepare for this test so you could do really, really well on it. So if your grades are not exactly where you want them to be, if you do really well on this test, it can't do anything but help you. And then also, that leaves us a Friday where it's the day before we all go for fall break. And those are kind of the days where you might have some people who miss because they're traveling early. But for those who are here, we're going to spend that time. You're going to turn your project in that day. If you haven't already, I think I've gotten one, but I haven't been here much, so I didn't expect to get many of them. And then also, we're going to do something else, but I'll explain that one to you later. But it'll be good. It'll be helpful to the grade good. So, anyhow, all right. Today, easy lesson, because we've now done all the different methods of factoring. So that leaves us to any type of polynomial that we can factor. We're going to solve by factoring today, meaning we take our factors after we've factored it completely, and then we set each of those factors equal to 0 and we solve. We've done this. Remember, we're finding where it crosses the x-axis. Now, what you'll actually see as being taken away from this is sum and difference of cubes, for example. And because of that, or the reason because sum and difference of squares are out of that. No, sum and difference of cubes, I apologize, is because the binomial sometimes gives you a irrational number, and sometimes the trinomial gives you an irrational number, and we're not dealing with irrational numbers this year. So therefore, we're taking those off the agenda. Okay? So we're going to work a few of these out. I think there are just 10. So seriously, guys, this is what we're going to do 5 right now, and you're going to have 5 for homework. Okay? I can't make this much easier. So I know that a lot of you guys, I say that, and you'll start working on it now, and that's fine. Just know my expectation is that you are quiet and polite to the sub. But anyways, let's get started. We'll do number 1. So again, we have to factor this. It's a binomial, right? And just like always, the first thing we ask ourselves is there a greatest common factor? And in this case, there definitely is. You can pull out 3x squared. Now, when I take 3x squared out of 12x cubed, 12 divided by 3 is 4. And then x cubed divided by x squared is just x. And then, of course, negative 3x squared divided by 3x squared. Some people are like, well, it cancels. Well, kind of. It does cancel, but what is 3 divided by 3? It's negative 1. So there they are, guys. I cannot factor these down anymore. I know that 4 is a perfect square here. I know that 1 is a perfect square, but x squared is not. So because of that, you cannot do difference of squares. So this is it. These are our factors. So what I need you to understand is anytime a variable has or anytime a factor has a variable, it's an important factor. So I'm going to take both of these then, because they both have variables, and I'm going to set them equal to 0. And I'm going to solve. Now, with 3x squared, don't overthink that. You divide by 3. 0 divided by anything is 0. And then again, remember how we get rid of x squared? We take the square root. And generally, hopefully you guys recall, what does that add to your answer when you take the square root of both sides? We've done that. Hopefully you remember that it adds a plus or a minus. Positive or negative could be your solutions. But here's the deal. Is there a difference between positive 0 and negative 0? Of course not. 0 is neutral. So it's just x equals 0. And then the other one, we're going to add 1. We're going to divide by 4. So either one of these two answers would be perfect. 1/4, or as a decimal, 0.25. So very simple, because we've already talked about factoring. Factoring is not new. We've already talked about taking your factors and setting them equal to 0. The difference is, because you have a quadratic, or it's not just a quadratic, you're going to have more zeros. You're going to have more solutions. Because, like this one, for instance, the biggest exponent is x cubed. It should have 3 answers. Well, does it? Well, it definitely has that one, but it has this one twice. It's what we call a multiplicity. I don't know if you recall me saying that. It's got a multiplicity of 2. We talked about what that means at the graph, how it would not cross through the graph, but it would actually just touch it and then turn back the opposite direction. But anyways, there you have it, okay? Moving on along, we'll do number 3. Number 3 and number 4 are very different. You're going to do number 4 on your own, but look at that, okay? There's no GCF, but it is something, so you can definitely factor and solve. Okay, let's move to number 3. Again, this one's very similar to the previous one. It's just our answer is going to be substantially different. I can definitely pull a 2 out, but I can also pull out an x squared. Now, when I pull 2x squared out of 2x to the 4th, I'm left with x squared. And then negative 24 divided by 2 is negative 12. And then, of course, the x squareds will cancel. Now, again, I'm going to take these and factor them as far as I can. Well, this is a binomial, but I cannot do difference of squares. Even though that's a perfect square, 12 is not. 12 is not. I cannot factor that. So therefore, I've gotten it to the point where I take my factors and I set them equal to 0 and I solve. If I could have kept factoring, I would have, but I can't. So I take my factors and I set them equal to 0 and I solve. Now, the 2x squared is very similar to the one we just did. You divide by 2, still 0. You take the square root, it's still 0. Remember, with a multiplicity of 2. It's your answer twice, essentially. Now let's see how the next one works. I'm going to add 12, positive 12. Then I'm going to take the square root. Now, when I take the square root, unlike the last problem, remember we're supposed to add positive and negative to my answer. But don't forget, we can break down the square root of 12, right? What's the biggest perfect square that goes into that? Divided by 2. 6, don't go above 6, so 4. 4 goes in there 3 times. So remember, 4, being a perfect square, gets to break out as a 2, and the 3 gets trapped inside. So my answer here is plus or minus 2 square root of 3. So once again, does this have, how many answers does this one have? We'll go back up here. It should have 4. Does it? Well, yeah, it has 0 with a multiplicity of 2 twice. It's got positive 2 square root of 3 and it's got negative 2 squared root of 3. That's 4 answers. Okay, everyone should have the same number of solutions as your biggest exponent. So there you have all 4 explained. Okay, let's go to the back side. And we're going to move along to a trinomial. Let me see which one I want to do. I think I want to do number 6. Number 6. Okay, if you look at number 6, look at every term. I can definitely pull out a 2. And then that term has an x cubed. This one has an x squared. And this one has an x. So I can pull out a 2x. Let's see what that leaves me with. 2x cubed divided by 2x is x squared. Negative 16 divided by 2 is negative 8. X squared divided by x is x, negative 8x. Negative 40 divided by 2 is negative 20. And the x's cancel. X's cancel. Now I'm going to hold on to that 2x. Now listen to me. Do not let this disappear. Whoops, I meant to use the highlighter. Do not let this disappear. Look, it has a variable. If it has a variable, it is an important factor. So don't let that thing just kind of disappear. You want to hold on to that because it's important. So now let's factor this trinomial. We know how to do that. We factor it into 2 binomials. What will multiply by itself to get x squared? Well, that's x times x. What will multiply by itself to get a negative? That's a positive and a negative. And then, of course, we're looking for the 2 numbers that will multiply to get 20, but have a difference of 8. Multiplies to get 20, has a difference of 8. Well, that's 8, or that's 10, 10 and 2. 10 and 2. And since that biggest sign right here in the middle was negative, it has to go with my bigger factor, the 10. That leaves the 2 with the plus, and that's how that little puzzle breaks out. Now, look, I can't factor any of those now. Look, 2x, x plus 2, x plus 10. So at this point, again, we're going to take all of our important factors. Remember what makes it important? If it has a variable. We're going to take all of them and set them equal to 0 to solve. So the first one's easy. Just divide by 2, and 0 divided by anything is 0. The next one we're going to subtract 2, so negative 2. And the last one we're going to add 10, so positive 10. So I have, let's see, I have 1, 2, 3 answers. My biggest exponent was x to the third. That's exactly what I would have expected. Okay? All right, I'm going to do number 8. Number 8 has a problem. It has a mistake. So here's what I need you to do on number 8. I need you to change this right here to a minus x and change this to a plus 2. Okay, so it should say x cubed minus 2x squared minus x plus 2. I'm just going to rewrite it because I think it's going to look cleaner. You just need to make this change. There was a little mistake, and it's one that we can easily rectify. So here we go. I want you to think for a moment. And the one that's like this on your homework is just below it and to the left of it. We're going to take these 4 terms, and we're going to factor by grouping. We're going to factor by grouping. So I actually might change my mind. This might be the last one I do. That means I have done 4, and that will leave 6 for you to do for homework on your own. So I think that's fair. Plus, you probably will enjoy me stop talking. So I'm going to factor this by grouping. That's the only way we've factored 4-term polynomials. And hopefully you remember what we're really trying to key in on. So first, let's just factor the GCF out of that first group. Well, only thing I can pull out of x cubed and 2x squared is x squared. And when I pull out x squared, x cubed divided by x squared is x. And negative 2x squared divided by x squared is minus 2. Now, the next one people get a little confused with. Remember, whatever this sign is out front, you have to use it. But a lot of people come to this problem and they're like, well, dang it, I can't pull anything out of x plus 2. And you're not wrong. You can't pull out something that's going to actually make it change big time. It will make it change a little bit because of this minus sign. But remember, if there's nothing that you can pull out in common, you can always pull out a 1. So minus 1, negative 1. Well, negative x divided by negative 1 is positive x. And positive 2 divided by negative 1 is minus 2. So remember what we said? How do I know that this was factorable? If what is left in these two binomials are identical, then it was factorable, and they are. So my two factors are what I pulled out, x squared and negative 1, so x squared minus 1, and the other factor is what I left inside. Now, you could take these and set them equal to 0 and solve, but I'm also going to hopefully recognize that this is difference of two perfect squares right here. So remember, that's the one time I can take a binomial and factor it into two binomials. Now the x minus 2 over here, I can't do anything with that. That one's done. But the x squared minus 1, remember, what multiplies by itself to get x squared? Well, x times x. What multiplies by itself to get a 1? Well, that's definitely positive 1 and negative 1. So now we've got this thing broken all the way down. So now we can take all of these factors. We're going to check ourselves here in a minute. Hopefully you know what I mean by that. I'm going to subtract 1 here. That's negative 1. I'm going to add 1 here. That's positive 1. I'm going to add 2 here. That's positive 2. And here's what I mean by check ourselves. How many solutions did I come up with? Positive and a negative 1, right? That's 1, 2. Positive 2, that's 3. Go back up to your original problem. What was your biggest exponent? X cubed. 3 solutions, okay? 3 solutions. Well, there you go. That is pretty simple stuff. I did 1 and 2, 3. I did 6 and 8. So your assignment, if you didn't realize it, is all the blank ones. That's 2, 4, 5, 7, 9, and 10. Should be pretty easy on you guys. I don't foresee you having any problems. Solve them when you're finished with it. I expect you to still remain quiet and not be obnoxious and distract the class. There's people who are possibly still working. But again, remember, this needs to be finished. We'll go over it tomorrow. Then afterwards, you'll get a review. You can work on it. We'll go over it on Wednesday, and your test will be on Thursday. All right? You guys have a great rest of your Monday.